So today we're going to be talking about arcs and chords. To start us off, we have Theorem 9.4. In the same circle or congruent circles, congruent arcs have congruent chords. So, if we draw little triangles, we can see that we form a little triangle where the radii are congruent because they're radii. And so all four of those sides of the triangle are congruent. And because we know that we have congruent arcs, so the congruent arc being this arc right here to this arc right there, then we know that the central angles are congruent. So now this triangle is congruent to this triangle by side, angle, side. And since the triangles are congruent, then you can say that these sides over here must be congruent. So that's how you would prove that congruent arcs have congruent chords. And you can kind of reverse that to show that congruent chords also have congruent arcs. Okay, another theorem. If a diameter is perpendicular to a chord, then it bisects the chord and its arc. Okay, so diameter, and I should add in there radius, because a radius is just part of a diameter. So we have a radius, it is perpendicular to a chord, then it's going to bisect the chord. So it's going to cut the chord in half, and it's going to cut the arc in half as well. So if we solve a little problem using that information, find the value of OE. Okay, OE, that's this line right here. Find the value of OE and AB, the entire chord, if OA is equal to 6, and angle AOE is 60 degrees. So let's label our angle. Okay, so what we know is that we're looking at the little triangle on the left. That interior angle is 60 degrees, which makes the other angle 30 degrees, so we have a 30, 60, 90. If the hypotenuse is 6, okay, here's a hypotenuse, which is 6, then the short leg, which is the distance from O to E, has got to be 3. And if that's true, then you can find the length of AE, because it's a 30, 60, 90 triangle, as 3 radical 3. So I can blow up the triangle, make it a little bigger so you can see it. If the hypotenuse is 6, then the short leg is 3, the long leg is radical 3, which means that AB, the entire length, is going to be twice that, or 6 radical 3. Okay, so I'd like you to try a couple of these problems. I'm going to work through this first one with you, and then you're going to pause the video and work the other two yourselves, and then in a minute I will reveal the answer so you can check your work. But let's do the first one together. We're supposed to find the radius and the measure of arc AB. So the first thing we want to do is find the radius. If we draw the line from C to B, then we can figure out, because we have a radius and it cuts the chord in half, then that length of that triangle is going to be 12. And if we know our right triangle Pythagorean triples, then we know that that hypotenuse has got to be a 13, because it's a 5, 12, 13 triangle. If you don't see that, you can just do the Pythagorean theorem and you'll figure it out. Okay, so the radius is 12. Excellent. That was the first part of the question. Now the second part of the question is to measure the measure of arc AB. In order to get the measure of arc AB, we have to find the measure of the central angle. And I'm calling that angle theta. Well, you can see that that central angle makes up two angles of two little triangles. So let's look at the little right triangle. So I'll go ahead and pull that out, and I've got a 5, 12, 13 triangle, and I need to know that angle. I'm calling the angle alpha. That's the little angle. I need to find the big angle theta, but first if I find the little angle alpha, I can just double it. So what is alpha? I can use trig now to find that right triangle trig. So I have an opposite side and an adjacent side. To find the angle alpha, I would say that the tangent of angle alpha is equal to opposite 12 over adjacent 5. So I do my inverse tangent on my calculator, and I find that alpha is 67 degrees. But alpha is just half of the central angle, so let's find the whole central angle, which is going to be 2 times alpha, which is 135 degrees. Therefore, the measure of, and I kind of rounded those off with your calculator, but the measure of angle of arc AB is 135 degrees. Okay, so go ahead and pause the video right now and try number 2 and number 3. If you want to talk to a neighbor, that's fine. Okay, I'm going to go ahead and reveal the answers so you can see what's going on. And I'll pause the video again and take a look at these and see if your answers match up and discuss with a neighbor if they don't. So go ahead and pause the video. Okay, we're going to move on. We have a whole nother series of questions, practice problems. Go ahead and work these together. Work silently on your own and then talk to a neighbor to verify your results. Pause the video now, and then when you're ready, let's go ahead and start the video again, and I will reveal the answers. Okay, here we go. Here are the results. So go ahead and pause the video. Oops, too far. Pause the video again and check your answers. Have any questions? Talk with your neighbors. Okay, so we're moving on. We have one last theorem. In the same circle or in congruent circles, number 1, chords equally distant from the center are congruent. 2, congruent chords are equidistant from the center. Okay, so let's start with the first one. Chords that are equally distant from the center are congruent. Well, we can do a little proof to show that that would be true. So if we draw a little triangle, we know that those radii are congruent. And if we draw the same triangle below, we know that those radii are congruent. And if we know that the distance to the chords are congruent, now we have basically a side-side-side situation, because we can show that these two triangles, because the chords are going to be cut in half, those sides have to be congruent as well. Okay, and here's an example problem. Let's say you were given this scenario. Find the value of x. So you recognize that that has to be a 3 because that's a radius, so it divides a chord. It's perpendicular, so it's going to divide in half, so that's 3 and 3, which means that whole length of RT is equal to 6. And if that length of RT is equal to 6, then we know that x must be the same distance from the chord that UV is. Oops, too fast, sorry. And we'll finally, we'll end with math humor. And that's it. Have a great day.